Welcome to This Explainer. Today, we're doing something super cool. We're going to pull back the curtain on how AI systems like ChatGPT, Claude, and Gemini actually function from the ground up. If you've ever felt completely overwhelmed by all the technical jargon surrounding AI, don't worry. We're breaking down exactly what a large language model is, and I promise absolutely no math is required. Just clear, fundamental concepts.
We've got a lot of ground to cover today. We'll start with the next word prediction machine, then dive into tokens, embeddings, and math. After that, we'll hit transformers and attention mechanisms, how these LLMs are actually trained, hallucinations and context windows, and wrap it all up with RAG, agents, and search.
All right, let's just get right into it. Have you ever wondered what is actually happening under the hood the exact second you type a prompt and hit enter? I mean, it kind of feels like magic, right? Like you're chatting with a thinking being. But the reality, it's a highly structured step-by-step process.
To figure out that process, we need to start with Section 1, the next word prediction machine. This is the fundamental truth of LLMs. So here's the core truth you really need to keep in mind. An LLM is not a giant encyclopedia of facts. It doesn't actually look things up. It's simply a next word prediction machine. Think of it like the autocomplete feature on your smartphone's keyboard, but scaled up to a massive billions of parameters level. You feed it text, it turns that text into numbers, runs it through a gigantic network, and spits out a probability for every possible next word. It just picks the most statistically plausible continuation, adds it to your prompt, and repeats the whole shebang, over and over again, incredibly fast.
But how exactly does it read your prompt to make that prediction in the first place? That brings us to Section 2, tokens, embeddings, and math. Basically, how machines read human language.
You see, models don't actually see words or letters the way you and I do. Instead, they see what we call tokens. Think of a token as the atomic unit of text. A short little word might be a single token, but a longer, more complex word gets chopped up into several pieces. As a general rule of thumb, one token equals about 4 characters of English.
Take the word unbelievable, for example. We read that as a single word, right? But the model might slice it up into un, believe, and able, 3 completely separate tokens. And honestly, this brilliantly explains why an LLM can confidently fail at something as simple as counting how many times the letter R appears in the word strawberry. It literally cannot see the individual letters. It just sees a couple of chunked up tokens.
But here's the catch. A neural network can't do arithmetic on a text token either. So it translates these tokens into embeddings. This is basically a long list of numbers representing the token's meaning as a physical point in a crazy high-dimensional space. The absolute magic here is that the relationships between words literally become geometric directions. The concept of moving from king to queen becomes a mathematical step the model calculates. Meaning translates directly into geometry.
So what exactly is processing all of these geometric numbers? Welcome to Section 3, the engine room of the AI, transformers and attention mechanisms.
Introduced by Google researchers back in 2017, the transformer architecture is the massive breakthrough that made all these modern LLMs possible. See, before transformers, AI had to read text sequentially, word by agonizing word. That was super slow, and it made the system forget earlier context. The transformer changed the game completely by processing all the words in a passage at the exact same time, in parallel.
And this is powered by a super clever mechanism called attention. Listen to this sentence. The trophy would not fit in the suitcase because it was too big. What does it refer to? The trophy or the suitcase? Well, attention allows the model to look at that entire sentence simultaneously and correctly figure out that it refers to the trophy. If you change the word big to small, the attention mechanism instantly flips that reference over to the suitcase. It's pretty wild. So the big question now is, how do we get this transformer network, which honestly starts out as just random mathematical noise, to actually become helpful? That takes us to Section 4, how LLMs are trained, from random noise to polite assistant. Think of it like a 3-stage assembly line. Stage 1 is pre-training. This is where it absorbs billions of words, learning language and world knowledge purely by guessing that next token. But that really just gives you a babbling model. So Stage 2 is fine-tuning, where we show it curated examples so it learns how to actually format responses like an assistant.
Finally, there's alignment, often using something called reinforcement learning from human feedback, or RLHF. Basically, human reviewers grade the AI's answers, shaping it into that polite, cautious, and on-task assistant you chat with every day.
Now, let's talk about where things go wrong. Section 5. Hallucinations and context windows. The structural limits of prediction.
When you're chatting with an AI, you got to remember its memory is definitely not infinite. It has a context window. That's the maximum amount of text it can hold in its working memory at any one time. Every single instruction, every document you paste in, and the entire back and forth of your chat history, they're all fighting for space in that window. That is exactly why, in a super long conversation, the AI might suddenly seem to forget a rule you gave it right at the start. That earlier text literally just fell out of the window.
And because the model is ultimately just predicting the next most likely token based on its training, we get something called hallucinations. Keep in mind it's optimized to produce plausible text, not necessarily true text. So if it doesn't actually know the answer, generating a really confident, well-worded guess is just statistically more probable than admitting it doesn't know. It will straight up invent citations or facts with absolute assurance. Just remember, confidence is not evidence.
So how do we fix those hallucinations, get around those knowledge cutoff limits, and expand what these tools can actually do? Let's check out our final section, RAG, Agents, and Search, grounding the AI in reality.
One massive solution right now is called RAG, or Retrieval-Augmented Generation. Instead of forcing the model to rely entirely on its static memory, a RAG system first searches an external database or the web to find fresh, verified facts. It grabs those documents and drops them directly into the context window right next to your question. Then, the model reads them and answers based on what it just read. This lets it cite real sources and drastically cuts down on those pesky hallucinations.
By giving these models access to tools like RAG, calculators, or web browsers, they really level up. They transition from just being simple text generators into smart agents that can execute multi-step plans. This makes them genuinely incredible at writing, teaching, coding, and extracting data. When you use them as force multipliers for tasks that are fundamentally about transforming language, they are honestly unmatched.
But the pros know exactly where the tool falls short. LLMs still struggle heavily with factual precision, super recent events without web access, complex, genuine reasoning, and consistency. The real secret to success here? Keeping a human in the loop at these exact edges to verify that final output. You gotta check their work.
And guys, this technology isn't just changing how we chat, it's completely rewiring search. AI answer engines are starting to replace standard web searches by synthesizing answers instead of just handing you a list of blue links. This introduces a whole new concept called Generative Engine Optimization, or GEO. If your content isn't structured cleanly so an AI can easily grab it, read it, and cite it, well, you basically become completely invisible at the exact moment a user is making a decision.
I want to leave you with this final thought to really ponder. 25 years of typing keywords just to get a list of blue links is coming to an end. LLMs are rapidly becoming the fundamental layer between our information and the world. So how will you adapt your work, your business, and the way you learn to this thrilling new era of synthesized AI answers? Thanks so much for joining me for this explainer, and keep learning.